Okay, good evening, everyone. Hope all of you are well. Can you guys hear me? Okay, that's good, Asan. Okay, so I think more people are going to join with time. Okay, so let's start with this. So today we are going to study how to do configuration management, specifically APN configuration management. This was something that was being asked by a lot of this students. So I skipped the rest of the feature part, and we will come back to the feature part afterwards. So let's just jump on to the configuration management, APN configuration, and the DPI, and then we're going to look. Then we're going to look after the other part of the configuration as well. Okay. Uh, uh, I hope my screen is visible to you people, right? Okay. Okay. So let's jump into it. Okay. Okay, so in configuration management, specifically when we look into the APN configuration, we're going to learn the APN related concepts. What is an APN? What are the related concepts of APN, and how to perform the data configuration for a cloud UGW APN. The commands will be specific to Huawei Cloud UGW, but similar sort of commands. I mean, similar. The concept is the same for all the other products as well. So once you understand this, you can correlate it with the other vendor cloud UGW as well. Okay. So as we studied before, there are two portions of an APN. One is your network identifier, which is this blue part, which is the APN which we commonly use, like an internet APN, WAP APN, IMS APN, MMSC APN. The other one is the operator identifier, which is basically used to identify the operator. This is something that's recognized by the DNS in the international standards, but this isn't something that we usually configure on our handset, or even something that we configure in our UGWs as well, in the PGSNs as well. But this is automatically pegged based on a base configuration of a node. Okay, so it's internet is the network identifier part, and operator identifier is your MNC, the mobile network code, the mobile country code .gprs. This is specifically for 2G, 3G, and for 4G, if you recall, it was .3GPP network dot EPC dot 3GPP network .org. So the main thing that we're concerned about is your APN network identifier. Okay, let me just recheck the recording is going on. Okay, right. So application of the APN. As you would remember when we were studying the DNS, there are two different DNSs. One is your internal DNS and one is your external DNS, or what we call a GN DNS and a GI DNS. The GN DNS responsibility mainly is to resolve the APN into a GGSN or a UGW IP address. Okay. So once your request comes here, you send a create PDP request, session request, so USN then collaborates with the DNS, and the DNS then gives your cloud UGW IP address against that APN. Why is that given? Because not every GGSN may have the definitions of an APN or the routing of that APN. In some operators, they like to differentiate the traffic based on their GGSN. For example, you need to keep a separate GGSN for your corporate clients. You need to keep a separate GGSN maybe for your internet traffic, the different GGSN that is serving your IMS traffic, and so on and so forth. So for that perspective, you need to define in your DNS, or for that perspective in the in the IPv4 host, your local host of your USN, you need to define that okay, which GGSN is handling this APN. So that when your request comes, the routing from a USN is directly done towards that specific GGSN that is handling that traffic. The other DNS is your internet DNS, which is the GI DNS, and its responsibility is resolving a URL like yahoo.com into an IP, because packet core communication is an IP communication, so you need to resolve it into a specific IP address. So your GI DNS then resolve into IP, and then this IP is what is used for communication with your user equipment. Okay, So there are three different access modes that a UE mobile station can use when it is accessing your internet traffic. Okay. The first one is called your transparent non-authentication mode. As you would understand by the terminology, it's transparent and does not need any authentication. So you send a create session request, no authentication is required, and GGSN based on its internal checks, as we studied that based on the APN, which IP needs to be assigned whether the service is allowed, and then it sends a GET session response. So no authentication is required by your radius server. The other one is your non transparent mode. In your non-transparent mode, you need to involve your radius server for authentication and charging. Okay. So in this request mode, the user is authenticated by the radius. Okay. And you provide a username and password in the PSO request, the QUV as in a radius proxy to communicate with the radius. So when you need to do authentication, obviously, along with your APN, you need to provide the username and password as well. If you guys would remember when we used to have the WAP APN, in WAP APN, we used to have the username and password as well, because the GGSN would then communicate with the WAP gateway, and then via the WAP gateway, your HTTP traffic was translated into WAP by the WAP gateway, and then it used to be directed towards your internet. So there, the WAP gateway used to act as a radius server, and it used to authenticate. Okay, and if you does not provide username password, the common username password must be configured in this APN. The other option we have is that if username password is, if the username password is something that is common for all UEs, so you need not provide in your handset. It is usually configured in the in your GGSN APN configuration, at which username password needs to be appended into your APN before going to your radius server or the web gateway for your authentication. And the third one is your transparent authentication mode. Okay. So in this access mode, a common username password must be configured on the APN. The cloud UGW uses the common password to authenticate the APN. Okay. So in your non-transparent mode, uh, uh, it's an optional. Either the UE provides the username password, or it can be configured in the APN. In this case, it is configured in your APN, and it's a transparent mode uh, by which you get authenticated, and then the access to your internet traffic is allowed for your user equipment. These three things, mostly what we use is this one. I'm just introducing it because during APN configuration, this option comes up. Okay, so a little bit of introduction of the different UI access modes. Okay, so this is how the APN selection mode works. Okay, if the UE or network provide the APN, the user must be subscribed to that APN. Okay, as we uh, studied in the HSS and HLR, when you're subscribed to a service, when your provisioning is done, and you need to enable your internet services, then your profile must be subscribed to that APN in the HLR and HSS. If you don't have an APN in HLR HSS, your service is not going to work, because you won't be authenticated. Your APN will be authenticated, and that profile will not be copied to USN, and you will not be able to use the internet service. If the UE provides the APN, the user does not need to subscribe to the APN. Okay. Uh, this is a specific case. Okay. Uh, on the HSS, there is a provisioning option available where if even if the HSS does not have an APN, or HSS have a specific APN, and you have a feature called there is a specific feature in your uh, SDSN that is called APN correction. Okay, so if UE provides an APN and you're not subscribed to that APN, you're subscribed to a different APN on the HSS. So you have a feature of APN correction, whereby the USN will auto correct the APN, and it will correct, or it will replace the user provided APN to the specific APN that you are provisioned to. And in that case, you do not need to, you will be provided the service according to the specific APN that you are subscribe to. Okay, and the network provides the APN. There is no need to subscribe to that APN. In that case, the UE does, even if you carry an incorrect APN, okay, then you will not be, if you carry an incorrect APN, the network is going to automatically correct you to that specific APN, and you can use the service accordingly. Yes, yes. This is what in APN correction, you specify a default APN, okay, and that default APN, I mean, if you have, for example, your one APN is internet, one APN is web, and you send in an APN by the name of ABC. So if you have that feature available, it will auto correct it to your internet APN, whichever APN you have defined to be your default APN, and your service gets you get service according to that specific APN. Okay. Now the next part, I mean, APN is just a name that will provide you with the IP address. Okay, so how is your IP address allocated? There are two methods. One is a static IP address, the other is your dynamic IP address. The static IP address is when you have a corporate APN and you don't want your IP to change, because every time you access the internet, you access your data services, you are usually, if it's not a static IP address, your IP address is going to be changed. Whatever is available in the pool, that is the one. So if you have a service whereby you need a static IP address, so you need to provision the static IP address in the HSS or HL. Okay. And in that case, when you subscribe into a service, you obtain that IP address from HSS and HLR when you're getting authenticated. If you don't need a static IP address, in that case, you are allocated a dynamic IP address. That is done via three different methodologies. Via a local address pool. This is what is mainly used, that is configured in AGSN, or it is provided by a radius server, or you have a different DHCP server. These two technologies are a little bit old. The DHCP was used in your old GGSN with the GGSN functionality. It did not have the IP allocation, so you to install a DHCP, dynamic source control protocol server, that used to provide IP addresses, and radius was usually used when you used to use the web services or your MMS services. But nowadays, majority it is done by your local address pool. Okay, so any difference between 2G, 3G, and 4G APN? The network identification part, no, there is no difference. The operator identifier, yes. In 2G, 3G, it's .gprs, MNC, GPRS, and in 4G APN, it's .epc, .mnc, .mcc, .3gpp network.org. Okay. And what is the difference between non-transparent and transparent authentication mode? In transparent authentication mode, it is authentication is done via your DGSN, and in your non-transparent mode, it is done by your Radius or any other third-party server as your authentication. Okay, so next we look into the APN configuration. The basic information about the APN. Okay, so before defining an APN, you must know what APN you need to set. If you get a request, because the network configured APNs are usually the same APN that go over the time, that is, a change is not required. APN configuration is usually required when you guys need to define a corporate APN. Okay, so for that, there are some sets of information that is provided by the corporate company, like they would provide you that what is the APN name, or what is the static IP address which they required. Maybe there is a specific DNS that they would like to add, then how it is going to be charged and all that. Okay, so the first thing is the name of the APN. Okay, so when you add an APN, the command is simple. It's add APN, and then APN name needs to be specified. Okay, so this is an example of adding a new APN. Okay, the next is the different configuration of the APN mode. So the first one is the access mode. Like we studied, there are three access modes: transparent, okay, transparent non-authorization, and non-transparent, okay, and local authorization. Okay, so when defining an APN, you need to specify which specific access mode is required. And once again, this is something that will be provided by the APN, by the corporate company, that which sort of authentication is required. Okay. And when you select that there is an authentication mode, then okay, how the authentication is going to be done. Whether it will be provided by the MSSDN, the username password will be provided by MSSDN, or whether it will be configured in APN or via the PCO message that is carried by the MSSDN. Okay, so this is an example. You sent the APN authorization attributes, you provide the APN name, and then you provide what is the access mode. So here it's transparent on authentication. So in that case, authentication mode is not required. In case you select something like transparent or an authorization or non-transparent and authorization required, in that case, you will have to provide what is the authentication mode. Okay. The next thing is on your GGSN, you have the option of specifying the maximum bandwidth value of an APN. This is a concept that we will study maybe a little bit later. I want to introduce this thing, that how your bearer, how you have a default bearer, you have a dedicated bearer. So the concept of your MBR, GBR, and your APN MBR, this information comes. Okay, so once you are assigned a bearer or you are assigned an APN, so that APN has a specific bandwidth value. You have the option of assigning that, okay, this whole APN can have how much maximum bandwidth in megabits per second. Okay, if you have a contract with a corporate customer, then you have a contract of the okay, uh, they are going to inform you that okay, we require this much of bandwidth. This is the maximum bandwidth that will be required by our customers. So you have an option of specifying that okay, all the users that are using this specific APN, cumulative their cumulative bandwidth should not exceed this. So you have an option of putting a restriction over here. Usually we do not have a restriction, but in case we have a restricted bandwidth available via the ISP, so we have the option of restricting the total bandwidth that can be provided to a specific APN. So it's done via this command set APN access control. You provide the APN name, and then you provide what is the maximum bandwidth that will be provided to this APN, and this is then provided to your mobile station in your APN AMBR. Okay. The other option is to specify how many number of subscribers can this APN support. You have an option of specifying that okay, that corporate APN requires, for example, 5,000. Okay, this is usually configured via the IP pool. You only specify those number of IPs which are required, but this can be controlled at APN level as well. Okay, so this is an example. You can set an APN access control. The APN is Huawei. The maximum bandwidth is 100 Mbps, and the maximum PDP numbers that this APN can support is 10 is 1 million, I guess. So this is a configurable value that can be configured. Okay, the next optional parameter for an APN is that you can set an idle timeout. The concept of an idle timeout is that if a user is connected to the internet and user is not doing any browsing, there is no uplink and downlink been done by that user, then that user is basically wasting their resources. The GGSN has a specified number of IP addresses available. The radio side has a specific number of radio bearers available. So if a user is not using any data services, then ideally that user should release all the resources that he is occupying. So we have an option available that is configurable on the APN instance at the APN level, and that is called the idle timeout. So we have an idle timeout switch where we can enable it or we can disable it. And once we enable it, then we can specify what is the idle time length. This is in minutes. Okay, so you can specify that, okay, if a user is not using any data, there is no uplink downlink for 10 minutes, then the user PDP, his session should be disconnected, and accordingly his radio services are going to be released. The other is your session timeout. Okay, session timeout works that irrespective of whether you're using the service or not. If you have a PDP session or a bearer session that is established, then then after some specific time, you are going to disconnect his session, irrespective of whether he is using this service or not. Okay, and the value of session timeout is usually larger than your idle mode. Okay, in idle mode, if a user is not using a service for 10 minutes, maybe you're going to disconnect. Okay, in session switch, it is a longer duration of time. For example, let's say 8 hours, let's say uh, 10 hours. Okay, and the concept of this is that in some cases the user gets disconnected and the user does not inform the code network that it has been disconnected. Or if you want to offload a user, uh, a very good example was given by a friend of mine, is that when they wanted to offload, they wanted to uh, cut over from one GGSN to another PGSN, or they wanted to cut over from one PCRF to another PCRF. So they basically configured this time to a lesser amount of time, like for 4 hours or 5 hours. So even if a user is continuously using the data services for 5 hours, his session is going to be disconnected after 5 hours. And since your new configuration takes effect in which you have changed the PCRF, so when he establishes another session, he will be assigned the other PCRF, or maybe he will be assigned another PGSN. Okay. So this is something, if you need to offload a user from a PGSN or you need to offload a user from a PCRF, so session timeout can be used for this perspective, perspective as well. Usually session timeout is not configured. I mean, the operators I have worked on, I don't see anywhere that session timeout is enabled. But yes, if you need to perform a cutover activity or need to perform migration activity, you can use this option to ensure that the users are offloaded from a specific GGSN or specific PCR. Okay, so the commands for verifying the APN configuration, you can list APN to check the APN name. The authorization can be listed, the access control can be listed, and its timer attributes can be listed as well. Okay, so this part is regarding the APN. This is how your APN is, and now how an IP address is allocated. Okay, so there can be two types of uh, IP addresses: a static IP address and a dynamic IP address. Okay, for a dynamic IP address, you can run the following command to set the IP address allocation. Okay, so the specific command, I mean, this is specific Huawei related command, but similar commands. So the first thing is you need to specify the APN address attribute. So you specify the APN name, and then you specify that this IP is to be allocated how? Allocated locally via radius server or via a DHCP. Okay, and then you have some optional parameters as well, like the IPv4 radius priority is enabled, like you need to give priority to the radius levered IP address. For example, you have the local IP address as well, and you have the radius. So in this case, you can specify that, okay, the radius provided IP is going to take priority. In case you have both local and radius available, the radius one is going to take the priority. Okay, so you specify that, okay, this APN is going to have an IPv4, is going to have an address that is going to be provided locally by the PGSN. Okay. The other option is that you can specify that this APN will only entertain those IP addresses that are provided by the radius server or by the DHCP. And same goes for your IPv6 as well, in case you're using IPv6. Okay. The other option is for the static IP addresses. Okay. For static IP address, you have this option available. You can enable or disable the static IP as well. So you have an option available, static IP enable. You can specify enable, and then you can also specify that the static IP route needs to be enabled. In case it is provided by the radius, you can specify the radius IP route, which should be enabled or disabled. And then you have an option of ignore conflict as well. For example, if there is a conflict between your static IP route and your radius IP route, then the configure have an option of whether disabling the conflict or enabling the conflict. Okay. If conflict is enabled, like ignore conflict enabled, then it is going to be ignored. And the priority based on this priority, whether the radius has priority or not, based on this, it is going to assign that specific IP route. Okay. So this is an example of static IP. You can set APN address. APN is Huawei. The allocation type is local. Static IP is enabled. That means that the IP address are going to be static IP address. Static IP route is enabled. Radius IP route is disabled and ignore conflict is. Okay. The next is your pool. So your IP addresses are basically part of your IP pool. Okay. So you have a specific pool name like the IP. For example, your APN is internet. So your pool name can be internet dash pool. Okay. So you have a pool, and in those pool you define how many IP addresses are basically available in this specific pool. So its command is to create an address pool. You create an address pool, add pool, the pool name, and then you specify the IPs are going to be provided either locally or remotely. Local means that the DGSN itself will have the IP address, and remote means that it will be provided by your DHCP. And then which sorts of IP are going to be configured in this pool? It's either IPv6 or IPv4. You can specify. Okay. Next is specifying the IP address segment for that local address pool. Okay, so you specify the pool name. The command is add section. Okay, in basically in one address pool, there can be, I believe, 2 raised to power 16 IP addresses in one section, and the limit of having the IPs, I don't think there is any limit in that, but an IP pool is basically divided into different sections. Okay. After this, I'm going to show you a real configuration, and by that you can understand that okay, uh, what does a section mean? Okay. Like let's draw something over here, and I will, or let me just take out some real configurations, and then I can show you that how it's done. Okay, if my screen is visible to you, okay, so this is an an IP pool, like APSN underscore pool is 02. Okay, so inside a pool we divide the different IP address into different section numbers. Section 0, section 1, section 2. Okay, so section 0, the IPs are going to start from 10.32.00 till this, and then the next IP from 128 are going to start in section number 1 and end in 32 the this, and then section number 0, section 1, then section 2 is then going to start from 10.33.0.0 till this. So the limitation in a section is that it can have maximum 65536 2 raised to the upper power 16 IPs can be configured in one section. And in one IP pool, I believe we can have 64 sections. Okay. The reason for making a section is that it is easy to manage the IP addresses. For example, you have launched, you are a new telecom operator, you have launched and you have so many IP addresses uh, uh, available. Like let's say you have 1 million IP addresses available. So if you assign all those 1 million IP addresses to one IP pool, and then you get a requirement that okay, you need to create a new APN and you need to take out some of the IPs from those 1 million IPs. Let's say 500,000 IPs needs to be assigned to a new IP to a new APN IP pool. In that case, you won't have an option of releasing those IPs without having any service impact. You will have to lock the APN pool. You may have to then create a new APN pool. You have to remove this APN pool. Okay, creating a section gives us the ease of operation and maintenance. Okay, like the IPs are going to be allocated from section 0. Once you section 0, the IPs 80% IPs are going to utilize, and the next users which are using a specific APN are going to be assigned IPs from section number 1. And when the section 1 is 80% utilized, then you come to section number 2. So in case you divide your 1 million IP into multiple sections, and maybe let's say you have 100,000 users available, in that case, we can say that okay, maximum 3 sections are going to be used. The rest of the sections are going to be idle. So we can easily remove those sections from this IP pool and maybe assign those IPs to another APN that requires uh, IP addresses from the same pool. Okay. So it's an ease of operation and maintenance, and it's an ease of for the EGSN to allocate the IP addresses sequentially from a specific section number. Okay, so you define a section, add a section, you specify the pool name, then you specify the section number, which starts from 0 and then incrementally. You specify what is the IP address type, it's IPv4, and then you specify the start IP and the end IP, which I already showed. Section 0, IPv4, start IP is going to be this, and IP. So maximum one section can have 65536 2 raised to the power 16 IP addresses. I think it's 2 raised to the power, yes, 2 raised to the power 16. So this is an example, and I've shown you the real life configuration example as well. So it is an add pool. You specify a pool name, then you add a section to that specific pool, and then you specify the what are the IP addresses. Okay, and here you can note that we haven't bound the pool to the APN. That part is going to come later. Okay, so we created an APN. Now we're creating an address pool, and now and after that we have assigned some IP address to this specific address pool. Okay, these are some maintenance command which usually you can utilize. Okay, is to lock an IP pool. Okay, lock an IP pool, address pool, when if you lock the IP address is pool are unavailable. For example, you don't want any more users to be using the IP address of this specific pool. Okay, like I told you an example that we need to offload, we need to remove some sections, so you can lock a pool, and after that, no more users are going to use the IPs from this specific pool, and then maybe you can add a new configuration, or you can create a new pool name, and based on that, you can assign that IP pool to a specific APN, and the users can start using the IP addresses from your pool name as well. Lock a section. I think we have an option of locking a section as well. I'm not sure about that. I'll check this part. I'll check this part and I'll let you know on this. Okay. So you can lock an IP pool, you can unlock an IP pool, and you can check whether what is the the status of a pool name by checking whether it is locked or not. Okay. Verification is list pool name, and the pool name will show you that it is locked. Okay, the third part is the configuring the DNS. If you remember that we have to specify the GI DNS as well, which will basically resolve all your URLs into a specific IP address. So the third part of the APN configuration is the configuration of a DNS. So you specify the APN name, you specify the master DNS IP address, and you specify the backup DNS server IP address. Okay, so you always specify, you have an option of specifying two DNS IP addresses. For example, if your primary IP address is not available, then the backup DNS IP will entertain all your requests. Okay, so for IPv4, you specify the two IP addresses, and for IPv6 as well. Okay, and then you can also specify that the first mode for selection of the IP is going to be local, what is going to be the secondary mode, and so on and so forth. Okay, so this is an example, and going forward, I'm going to show you a real example as well regards to the APN. So set APN DNS, the APN name, then you provide your primary IP address of the APN, and then you have the option of providing the backup IP address as well. Okay, so this is an example, a real example. Okay, I think this is going to be more easy for you to understand. So you specify a pool, add a pool, you specify a pool name. For example, it's KE1 underscore pool. Pool type is local. The IP version is 4. Its release time is 5. So after 5 minutes, the pool IP, the IP that is basically uh, held by the user can be released. Okay, you specify a VPN instance. A VPN instance where, and we will discuss more configuration. I'm going to explain what a VPN instance is. Basically, we specify different VPN instances for different IP pools in order to streamline its routing via your IP core. Okay, so, so this is something that is compulsory, that you need to specify which VPN instance will be used by this specific pool. The next command is add section. You specify the which pool is it. Then you specify section 0, its start IP address, its end IP address. For example, section 1, start IP address, and the end IP address. Then you add an APN. So this is the name of the APN. It has VPN enabled, and then which instance is going to be VRF underscore GI. The next is assigning the APN address attribute. So we specify that its IP allocation is going to be local, and it's going to have a static IP. Okay. Next is the command to bind your IP pool to your APNs. So the command is add pool bind APN. So this is the pool which we defined here, and this is the APN which is defined here. Okay, and based on that, you are going to, let me just open up the chart over here so you can know, and then you can bind your pool to the specific APN. Some optional configurations like which will be involved in your DPI is if you need to have the PCC, the PCRF function. So you need to specify whether this APN will be utilizing the PCRF services or not. So you have an option of home PCC switch. If user is roaming in your home location, whether the PC switch is enabled or disabled, if it is roaming, in that case, and if the user is outbound roaming, then the PCC switch needs to be enabled or not. Usually for corporate APNs, we do not use PCRF because the corporate APN do not have very lengthy or very complicated policies. They usually have a single policy, so PCRF usually is not involved. Okay. The next part is your charge control. Charge control is basically to specify how, if a user is assigned this APN, then how is that user going to be charged. Okay, so we have two switches, whether it is going to be charged online, whether it's going to be charged offline. So we have the online switches enabled and the offline switches enabled. And this is the DCC template. The DCC template basically specifies that which OCS is going to be used. Okay, the OCS information, specifically we have different configurations of diameter. So once we are going to discuss the OCS configuration and the DCC templates, so this will be covered over there as well. Okay. The next part is to assign a user profile. Okay. So once you have an APN, you have an IP pool, and a user gets an APN, then what rules and which filters and all that, what like in specific terms, what sort of DPI configuration will be assigned to a user that is using this APN. Okay, so that is mapped via a user profile group name. So this APN is going to use a user profile group name UPG corporate APN. This thing we are going to discuss once we are going to discuss the SA and the DPI part. The next part is assigning the specific DNS IP addresses to this APN. So you have a master DNS IP address, the primary, and this is the backup DNS IP address. So when the user uses this APN to access internet, these are the two DNS servers that are going to be assigning it their resolution of your URL into specific IP addresses. Okay. The next is your APN timer attributes. Your APN address. Then, if you need to enable the idle time switch, it will be enabled. You need to specify the time. Then you need to specify idle update message. Idle update message you can see in the detailed TEDx or the documentation is that if before disabling the user session, you have an option that the GGSN can send an update message to the SDSN to check whether its session is still created over there. If a session is created over there, in that case, it is not going to delete this session. It will keep on enabling the session. But in case the SDSN does not have a session available, then it is going to delete the current session created on GGSN. Sessions time, this is the session timer, and this is disabled. You have the option of enabling it as well. Set APN access control. The access control, as we discussed, we can specify what is the maximum bandwidth, what is the maximum GBR, and what is the maximum PDP number. Tayyip, slides we will see if I can share or not. Okay, I'm not committing on this. We'll see if we can share it or not. Ahsan, fields are compulsory. When you will perform this varies from vendor to vendor. If you are going to log into your GGSN, so you can see that which fields are compulsory and which fields can have default values. So this is something that varies with the node that you're using and all that. Okay. How can we check the pool is finally GGSN assigning apparatus a new defined pool? This is by checking the utilization of the pool. When you display an IP pool, you will see that how many IPs have been used from this IP pool. Okay, and that way you can easily using the operation and maintenance commands, so you can easily check that how many users are specifying this APN. And once again, this is display APN user info. Yes, it's correct for Huawei node. For the other vendors, it is going to be a similar command in order to check. Okay. How to allocate an IP address for specific APN user? It can be via static IP address and it can be via a dynamic IP address. Static IP address is provided by your HSS, and dynamic one, you need to configure an IP pool, and then you have to specify a section, and then section you need to specify the IP address. and then you bind that IP pool to an APN in order to assign an IP address to a specific APN user. Okay. Next, we are going to look into an APN mapping. You must have understood. You must have heard two terminologies. One is virtual APN and one is the alias APN. So we're going to have a little bit of overview of what these two things are. Okay. So what is a virtual APN? If you can look into this diagram, there is one user that is requesting the internet service, and then another user requesting internet service, and they're using a virtual APN. So virtual APN is then actually mapped to the actual APN. Okay. The lead static APN we covered. This is done by HSS. Okay, you define it in the HSS. When your profile is configured in the HSS, you define the APN in the HSS, and then in HSS you specify that this user is going to have which static IP address. Okay, coming back. So that's virtual APN is then mapped into the actual APN based on different configurations which you have defined on the PGSF. Okay, a virtual APN can enable multiple subscribers who access cloud to use the same APN. Based on the configured virtual APN, the cloud user selects an actual APN to process the PDP request. Okay. So both if I activate a PDP request and Asan activates a PDP request, maybe we're using the same APN, but the actual APN that is providing us services can be different. That depends on various things which we can see in the future slides. Okay. Okay, so what is the advantage of this? Okay, the virtual APN helps minimize the number of used APNs. A user on a view geography can access the actual APN by means of a virtual APN. When virtual APN function is used, only one APN is used instead of all the APNs that may be accessed by user is set on the HLR and DNS. The virtual is also set on. Okay, so this is one of the live example is that okay. For example, your company decides that okay, we have some APNs available, and maybe we need to define and we need to introduce another APN. Like one APN is internet, one is web, and the company decided okay, we need to use another APN that is internet too. If you define a new APN, then what you need to do is that you need to do the provisioning of all your subscriber base in the HLR, and then the HLR nature you need to define for every user. You need to define that okay, another APN needs to be added, and then you need to inform or each of your subscriber base to manually configure the new APN, or maybe you push the internet settings to all of your global subscriber base, intimating that okay, a new APN has been added. So this is something that requires a lot of effort, that requires a lot of configuration changes and all. So an easier way is that you can define like a user is using a specific APN, like a user in this handset is using internet APN. So what you can do is that you can configure on the PGSN, and you can assign that the internet is now a virtual APN, and your actual APNs are maybe internet 1, internet 2, and internet 3. And then you can map your internet, the virtual APN internet, to the multiple new APNs which we have created. So this is one example of how your virtual APN can be used and is usually used. Okay. Or for example, you have multiple operators, you have national roaming available, or you have Hawken available. In that case as well, you can utilize this functionality of a virtual APN to map a single APN to multiple APN based on what sort of service you need to assign to a specific user. Okay. To map the service of an APN to another APN, they can map the APN that is carried by the user to an alias APN without changing the network planning and APN configuration. Okay. So the different APNs can be mapped to the same APN, and the mechanism facilitates the allocation and integration of different sources. This is basically definition of an alias APNs. So we are going to look into how the Alias APN is used. Okay, so this is an example. Okay, a user is coming to your MME and then your SGW and then to your ETW, and these are all the fields that are carried by the your create EDP request or your initial access request. Okay, so you have the option of mm, mapping your virtual APN to an actual APN based on any of these fields. For example, you can specify that okay, IMSI 1 to 10 should go to APN 1, IMSI 11 to 20 should go to APN 2, and something like that. Or you can map your virtual APN to the actual APN based on the RAT type as well. For example, the 2G, 3G user should be assigned a different APN, and the 4G user is assigned a different APN. Okay, and you can do it based on your PLMN. You can do it based on your serving group node, roaming. So there are multiple options available based on which you can map your virtual APN to a specific actual APN, uh, depending on your requirements and your traffic optimization. Okay, so this is an example. Your virtual APN is this Huawei, and your actual APN is Huawei 1 and Huawei 2. So both the user 1 and user 2, are going to bring the same APN. Okay, and then you have an option of uh, mapping type. So here the mapping type is port balance. So one user is going to be assigned Huawei 1, the other one is going to map to Huawei 2. Your mapping type can change. It can be based on your IMSI segment, based on your IMEI segment, MSI segment. So based on this specific mapping type, a specific user is assigned a real APN. Hassan, in which it will be assigned with IP pool, virtual APN, or actual? No, it's assigned with the actual APN. Virtual is just virtual APN. Your actual configuration will be done based on your actual APN. So the IP pool of Huawei 1, the IPs from the IP pool of Huawei 1 is going to be assigned, and IPs from if a different IP pool is used by Huawei 2, those IP is going to be assigned. Usually, what we do is that if there is a specific requirement, we differentiate the IP pool. Other than that, what I have observed recently in operators is that they use the same IP pool. So so I have an IP pool. For example, it's Internet Pool 1. So that Internet Pool 1 will be assigned to Internet 1, and it will be assigned to Internet 2 as well. So unless you have a specific requirement to differentiate the IPs of two different IP pools, you can use the same IP pool for different APNs as well. But to answer your question, it is going to be based on your actual APN. The configuration will be for this one. This is just a simple command of virtual APN. This virtual APN is not going to have any other configuration like its timer attributes, DNS information, IP information. All that is going to be configured with respect to this one, your real APN. Okay. Alias APN is basically the opposite of your virtual APN. What Alias APN does is that users that are bringing in different APNs that are basically mapped onto a single APN. So maybe I'm bringing an APN internet, Asan is bringing an APN web, a third guy is bringing an APN web. So I have an option of basically I don't have a differentiation of these three APNs. Okay. At some level, my company decided as okay, there are so many APNs available, and we need to just have configuration of an APN. We don't need any other APNs. Okay. So what we can do is that we can delete the configuration of those specific APNs in the PGSN, and we can assign those APNs to be alias APNs. So the configuration will remain for the actual APN, and irrespective of what APN the user brings, I don't need to touch the user's configuration in the HSS HLR. He can use the old APN, but actually my routing is going to be done based on my actual APN. So alias APN is the opposite, like your virtual APN is 1 to any, and this is any to 1. Okay, and its example is that, for example, you have two operators that have merged, like recently happened with Jazz and Varit. So Varit subscribers had the different APNs, Jazz subscriber had the different APNs. So once the merger was done and you had a single core node, so the single core node has just one real APN. And the Varit user would bring their own APN, the Jazz user would bring their own APN, and those would be then mapped to a single APN that is provided by a single PGSN core node. Okay, so a simple concept, the alias APN concept is simple. Okay, so let's have review the summary of this. The alias APN, the concept is to put forward implement compatibility with multiple APNs. Okay, when an operator wants to map the service reference to same APN, like any to one, or map the service of one APN to another APN, the APN carried by the user can be used as an alias APN. The virtual APN attributes carried by the users such as IMSI, MSSDN, RAD, PCO, the same APN carried by user mapped as different APNs. So I can have the option of segregating the real APN based on the IMSI, MSSDN, all these parameters that are carried by your create session request. The operator can provide user with different access policy by planning only one APN for the entire network. In other words, the workload of the operator is transferred to the device operator, and this mapped APN invisible to the user. Okay, so this is invisible. You can create more and more APNs in the backend, and the user and your devices are just going to have a single APN, and that is then going to be mapped to a different actual APN based on whatever strategy the operator is utilizing. So in easy terms, the alias APN ensures compatibility with old services. Like I just gave you an example that two operators have merged, and or maybe the company decided that okay, we're going to have one APN, so the old APNs can be merged into a new APN. Okay, the virtual APN aims to develop new services. Like you are defining new APNs, the handset just has an old APN, but you are basically developing new APNs based on your service requirement, and based on that, the virtual APN helps you in developing the new services. Okay, so how to create a virtual APN? This is how your virtual APN is created. Enable virtual APN, add an APN, and then you specify whether this APN is virtual APN or not. So this is an example. The APN name is isp.com and the virtual APN is in it. So GGSN is going to recognize, okay, this is not an actual APN. This is a virtual APN. And then you configure the mapping of virtual APN with the actual APN. For example, add virtual APN rule, and then you specify the virtual APN name. So this is the name of the virtual APN. And then you specify that how this virtual APN is going to be mapped onto the real APN. So it's based on IMSI, based on MSIDN segment, based on RAD, based on radius. So all these are options which are available, whereby your virtual APN is going to be mapped onto your real APN. Okay, so this command is, and you have an example here as well. So virtual APN is this, mapping time is MSSDN, mapping value 138 means that all the MSSDN that are starting with 138, they are going to be mapped to the real APN e-commerce. And for example, all the APN starting 137 may be to map to another APN. So this is an example of virtual APN. How to create an alias APN? This is an example. Add alias, APN alias. The alias APN name is this, and the actual APN is this. Okay. So its example is isp1.com and the actual APN is isp.com. And how to verify this list APN alias, APN time, APN type. You can test the APN alias using either the alias APN or the real APN name. Okay, and then you can specify the name of the alias APN. So it is going to give you that okay, these alias APNs are mapped to this real APN. Or if you list it with the real APN, there is going to this APN is basically being mapped by these three alias or two alias. Okay, so I believe the difference between a virtual APN and alias APN is clear. Any other confusion or any other queries regards to your APN? Because the APN portion I believe is complete. Okay, one more thing is left, so you can ask any question and then we can move to the IP lead function. Okay, so no question means either everyone understood or nobody understood, right? Yes, Ulfakar, you can type your question. Look, what virtual APN does is this. Virtual APN is many is one to many. Okay, you have one virtual APN, and maybe you decide that in order to optimize your service, you need to assign different APN to the user based on different characteristics. Which characteristics we saw over here? These are different characteristics. Okay, so for example, I decide as a telecom operator that okay, I have IMSI starting from 41008 and then 12345. So I say that okay, 41008 one. Like I'm going to type it over here to give you a better understanding. Okay. Okay. So I decided okay, this is my IMSI segment. Okay. Then I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Still 41008 and 99999. Okay. So I decided, okay, I need to, what I need to do is 41008 1000 till 41008, and I'll say 199999 should be assigned to APN1. And the traffic of 41008 to till 41008 and maybe 9999 should go to APN number 2. Okay, it can change. It can be based on IMSI. It can be based on MS size DN. Okay, so this is an example. So a user is going to bring the same APN. For example, in my handset, I have an IMSI. User 1 has an IMSI. This one. His IMSI is this 41008 1111111. Okay, and user 2, his IMSI is 41008 and 888888. Okay, and both of us are using the same APN. The APN configured on a handset is this one. Okay, so once our request, this user is going to be handled by the same, let's say GGSN1, and this one is also going to be handled by the same GGSN. Okay, so once my request, user 1 request come to GGSN1, I'm going to check that okay, internet is an virtual APN, and then I'm going to say that okay, this is mapped to either APN1 or APN2, and based on what? Based on my IMSI segment. So my IMSI, user 1 IMSI is being matched in this segment, so I will be provided, user 1 will be provided services from APN1, whereas this second user has an IMSI segment, this one, and this lies in this one, in this segment. So user 2 is going to be provided services from APN2. So in user 1 and user 2 handset, the APN is going to be the same. But so that is why it is called a virtual APN. The actual APN is going to be APN1, APN2, and that can be done based on IMSI segment, that can be done based on MSIG, and maybe I decided okay, 2G and 3G users should be assigned APN1, and 4G should be assigned APN2. So this is another example. Okay, and alias APN is the opposite of this. The alias APN, what does is that I have a user. For example, this is the user one. We are going to use the same okay. User one is this one, and user two is okay. For example, this user is bringing internet one, and this is using the APN internet two. Okay, and we are both coming to the same PGSN. So what I have configured is that internet one will be mapped to internet to maybe APN1, and internet 2 will also be mapped to APN2. So irrespective of which APN I bring, I will always be mapped onto APN1. Sorry, it will also be mapped to APN1. So irrespective of that, whatever is configured in my handset, irrespective of that, what MG segment I have, if I am bringing internet one, I will be assigned to APN. My service will be provided by APN1, and if I'm bringing internet two, again it will be provided by APN1. So maybe like 5 years back, I had these two different APNs configured in my network, and then later on, I decided that okay, I do not need two different APNs. I also need I just need only a single APN. So I will assign these APNs to be the alias APNs, and I will define a new APN, and this new APN is going to be done. Okay. Yes, all APN configuration is in UGW. Yes. Specifically, if you are looking into the CUPS technology, the cups, it's in CGW. You configure it in your centralized gateway, and it is reflected in your distributed gateway as well. But this is all done in your CGW. Okay. So I hope the virtual APN and the alias APN configuration, the clarity between these two. Any other questions? Somebody raised their hand, but I did not see the question. I think who was it? Zubair, I guess, or Zulfikar. No other questions. Okay, I think so. We can proceed to the next part. Okay, this is the configuration of the IP lease. No, SDSN does not have the alias APN. On SDSN, the configuration is SDSN basically has the functionality of routing your APN request to a specific PGSN. So alias APN is not defined on uh, on SDSN. It's defined on PGSN or in PGW end. On SDSN, we have the option of that I told you the APN correction feature. In APN correction feature, we can specify that okay, if there is an incorrect APN, then the default APN that should be assigned is this APN. So this is configuration is done in SDSN. What is the purpose of virtual APN? We can assign other APN to user space when the user like is trained for alias APN. Yasir, a virtual user, I just explained. If you can see here, okay, this is used to ensure that okay, alias APN that your old is moved and your virtual APN is basically used if you need to segregate your traffic based on some specific parameter. Okay, I gave a very good example that if you need to distribute your APN traffic based on your MG segment, or you need to distribute the traffic based on your RAT type, or based on your MSISDN, or based on your TLMN. So you can distribute the APN, okay, based on that. So your virtual APN is going to be the same one, and your actual APN is going to be a different APN based on how the distribution parameters you have specified. Okay. Clear or not? Yes, sir. Still confused? Look, Yasir, I am a telecom operator. Okay, I get a requirement that okay, your IMSI, you have IMSI segments that are starting from here. Okay, or for example, we'll just use it like this. Okay, my IMSI segment starts from here from my global subscriber and it ends here. I get a requirement, or I have my own requirement that I need to distribute the traffic. I need to assign different APNs to subscriber based on the IMSI. For example, if my IMSI lies between these two IMSIs, I should be assigned this APN. And if I have an IMSI between these two segments, I should be assigned this specific APN. So this can only be done when I have a virtual APN option available. In my handset, okay, one option is that for all those users that have this IMSI segment, I send an SMS to them, or I send a configuration message to them, and I ask them to please install this APN in your handset. I will not be able to provide you services using this APN, but this is something very hectic. Some users are going to use this APN, some are not going to configure it, some are going to configure it incorrectly. Okay, so an easier way is that I don't touch the subscriber handset. The handset will have the same APN, but based on the IMSI segment, GGSN provides me an option of distributing my traffic to two different APNs based on what IMSI segment I have. Or this can be used with different MSSDN as well. For example, my network number starts from 0300 1111 till it goes to 0309 1111. Okay, so my requirement is that okay, all the numbers starting from 0300 till the series of 0305 should be assigned to APN 1, and all the users that are starting from 0306 till 0309 should be assigned APN 2. Okay, one option is that I send a message, but that is going to be a hectic process, and that is going to be a very time taking process. The other one is that I can control it from my uh, network as well, where I can specify that okay, this MSISDN segment, if it brings internet, it should get this APN, and if segment is this one, it should get APN number 2. Okay, so now it's clear. Great. Okay, the next concept is the function of IP lease. Okay, so first we need to understand what is IP lease. When subscriber using PS services and they are deactivated a fault, such as network fault, terminal fault, software fault, the IP lease function enables them to allocate the original IP address to subscriber who are activated a short period of time. This provides bottom layer data channel guarantee for resumable data service subscriber services, improving the subscriber service experience. Okay. For example, I am using internet service and I get an IP address. Let's say this is the IP address which I get. Okay, my MSISDN is this, and I get an IP address of this 10.101.1.1. Okay, and there is a fault in the network. Okay, for a few seconds, like let's say a fault of 5 seconds. Okay, based on which my session gets disconnected. Okay, fault of 5 seconds. Maybe the OCS got down. Maybe my radio service got down. Okay, radio service got down or something like that. Okay, and this IP address is basically registered in OCS. This is registered in PCRF as well. Specifically, what I have noticed is that for PCRF, okay, this IP address is registered in PCRF as well. So once this OCS fault gets resolved and I activate a session within after 5 seconds, or say, let's say after 10 seconds, I activate a new PDP context. Okay. So if this IP lease function is not available, then I may be going to be assigned a different IP address. Let's say I get this. Okay. But my session may be at PCRF and was not terminated successfully. So once my session gets activated and I take a new request towards the PCRF, the PCRF is going to say that okay, this user, this MS has DNS this, and the session that I currently have has this IP address, but this user is bringing this IP address. So this is a conflict. Because of that conflict, the PCRF maybe will not be able to send a successful CCA response. If it does not send a CCA, then I will not be able to use it as services unless my session for PCRF gets disconnected as well. This usually happens when there is a network glitch, and I mean if it is a user initiated disconnection, in that case, it is usually informed to all the nodes. The USN knows, the UGW node, you will inform the USN, it will inform PCRF as well. But in case there is a network glitch, maybe USN knows, maybe UGW knows, but maybe the OCS is not informed, maybe PCRF is not informed, maybe other nodes are not informed. In that case, your session gets remained over there for some time. And if you activate a new session and you bring a new IP address, then that is going to cause a conflict resulting in your data services getting impacted. So we have an IP lease function, and the IP lease function is that even if your session gets deactivated because of a fault, GGSN can ensure that it can reserve the original IP address for you for a specific amount of time, so that if after a few seconds, let's say after 5 seconds or 10 sessions, you bring another PDP request, then the GGSN is going to assign you that same IP address. So if you get the same IP address, then the PCRF will recognize that okay, this side, then it will continue to provide you the service, maybe the OCS or maybe any other node. Even your charging gateway has your CDRs are created and your IP address based on the IP address. Okay, so if you have this IP lease function available, then your service interruption chances are less in case of network fault and network glitch. So this is the concept of your network IP lease. Okay, so this is an example. UE sends an activation request, node will apply for an IP address. Node B sends the request to MME, later the request for order SWW and PGW. This thing we already discussed. Checks whether there's an IP address matching the MGV in the lease IP address pool. Okay, if your session got disconnected, but the GGSN is reserving that IP, it reserves that IP in the leased IP pool. Okay, so it is going to check that okay, this MZ has any IP address in the lease. If it has that in the lease IP pool, it is going to assign you that same IP address, which will result in you getting the same original IP address. If no, usually proceed for the retrieve an IP address from the free IP pool address. Okay, so the lease IP, those IP which are not part of the lease IP are from the free IP address pool. So usually reserve the IP address from the free IP address and allocates it to the user equipment. Number 4, then the usually sends an activation response message providing your allocated IP address. The node will send the activation request, carry the IP address to the UE subscriber. Okay, so virtually what you can understand is that the IP address pools are divided into three portions. One is your assigned IP pool. These are the IP pools which are currently being used by active users. Free IP address pool are those IP addresses which are not being used anywhere, and lease IP address pool is those IP addresses which are currently not being used by any user but were recently used by some specific subscriber. So it is hold on in this IP pool from some for a specific amount of time, which is configurable in GSN, and this and IPs from these are not assigned to new user. These are assigned to those user which have the matching IMSI available in this IP pool. Okay, its functional impact: sufficient IP addresses need to be reserved in address pool for which IP address is enabled. IP address release cannot be allocated to new subscribers immediately. Okay, this is an um, negative impact of that. Okay, so if you have some IPs which are reserved in this address pool, and maybe you don't have any IPs in this IP pool, then the new subscriber will not get any IP address allocated. So this is a negative advantage or a negative impact of having this IP lease function enabled. Therefore, sufficient IP addresses need to be reserved during planning to prevent subscribers activation failure due to insufficient addresses. If you activate a service request and there are no IP addresses available here, then your service request is going to be failed with the cause code that no addresses are available. Okay, insufficient address. And this is some recommended methodology to assign that. Okay, what should be the number of reserve IP addresses? So this is configurable, and once you plan a network and you need to enable the IP lease function, so you need to check that what is the activation rate. Okay, you need to check how many online subscriber duration, average count, and then based on that you can specify a specific value of IP lease function, that okay, for how much time your IP lease is going to be assigned. Okay, so this is an example of data configuration uh, on how to configure this IP lease function. Okay, so configure a GGS and bind the address to a pool. So you configure a local address. We have already checked this. We bind the address pool to a VPN. You already know how to do this. Enable the IP lease function and configure the time that you will to release subscriber IP address after it is deactivated. So you add a pool. This is the name of the pool type, and then this is the command that is configuring that for how much time you need to lease the IP address. So release time 20 means for 20 seconds, this specific IP pool or this IP pool is bind to this specific APN. So any user that is using this APN will have the option that if it gets disconnected, it will have the option of retrieving the same IP address within 20 seconds. After the 20 seconds have passed, okay, so a session is disconnected, that IP address is placed in this lease IP pool for 20 seconds. Once 20 seconds have passed and the user does not come again, then it will then move from this lease IP pool to free IP address pool. Asan, this is configurable based on planning. Like its recommended methodology of calculation is mentioned here. So it is done based on what is running in your network. Okay, your activation rate, your online duration of a subscriber. So this is usually done as the planning phase. Okay, so your release time is configured here, and your VPN instance is enabled, and then you configure a section of this pool, specify the IP address in this section, then you define an APN, and then you bind this APN to this pool. So any user that has this APN will be assigned IPs from this pool, and any IP assigned from this pool will have an option of getting this release time of 20 seconds available. Okay, so how many parts is a 3GPP defined APN composed of? Okay, in we studied it, we have the network part and the operator identifier. Which attributes can be used by to map a virtual APN to actual APN? We check this as well. There are many attributes: MSISDN, IMSI, RAT type, PLMN, and so many more. And what are the dynamic address allocation mode? We also check this, that it can be done locally, it can be done via radius, and it can be done via DHCP as well. Okay, so this part concludes the configuration of the APN. Okay, you must have understood how to configure an APN, how to configure an IP pool, how to assign IPs to an IP pool. Okay, so I'll just list down the steps that once again for you, by which you can understand that how this can be done. Okay, so you define an APN. Okay, then you define APN attributes. Okay, the time that it's idle values, the time related values. Okay, then you have your bandwidth related values. Okay, and so on and so forth. Then you define the APN. Okay, in attributes we have this as well. Then you define its DNS as well. Okay, then you define an IP pool. Then you define section of an IP pool. What we can do is like this. It can be like this. Define the section of an IP pool. You define the IP range in your IP pool. You can define your IP lease function here as well. Okay, and in the end you map your IP pool to your APN. Okay, so these are the main three steps which you need to configure in order to ensure that you have that as well. Okay, and then we have an option of virtual APN as well. You know how it's done, and then we have a alias APN as well. Okay, so in configuration of APN, these are the main thing that you need to understand. And then there are some things that are specifically provided. I mean, if you have a corporate APN, you may need some more options as well, defining on that. Okay, right. Let's see if you have no. I think the APN part is complete. The essay principle and data configuration is a lengthy topic and it is a time consuming topic. So I think we can do this next week. For this time, the APN configuration should be enough. What I would request you all is that since all of you are PS4 experts or earning PS4 or working on PS4, so you should look into the configuration files of your network and you can identify that okay how which APNs you have defined, whether you have the virtual APN defined or not, whether you have alias APN, whether you have static IP, how many IP pools do you have, how many APNs do you have, how many sections in each IP pool do you have, the lease function enabled or not. So I think based on today's session, I think you must be capable enough to looking into your configurations and identifying what APN related information do you have. Okay, and still if you find something that maybe you need to understand or something like that, you can always approach to me and we can discuss it one to one to see that what is okay. Okay. Asan, DPI, yes, we will cover DPI, but it is going to be a bit complicated lecture. So maybe what we can do is that we can divide it into two parts because it's and what I would like you to do is to then I mean this APN configuration is a little bit complicated, so you should check your configuration, and even when we cover DPI as well, it is a very extensive topic. So you will need to configure your, you need to consult your own configuration as well based on that. And if you think that we should cover the lighter topics first, like how to configure a BSC, RNC, HLR, we can do that first so that you can have an understanding of configuration and then maybe we can move to DPIs. So it's all your call. Basically, 2 weeks ago, I got the feedback from Asan and all of you guys. So the majority of you were insisting that you need to understand the APN and the DPI configuration and all that. So I have prepared that. But if you think that it would be difficult for you to understand at this time, then we can do that. We can do the lighter topics first, and then maybe we can come towards this DPI. Okay. So you can let me know by Monday which topic should we cover next, and we can follow that sequence of topics accordingly. Okay, fine. So okay, thank you everyone. Thank you for being part of this session. Hope to see you guys again next week. Inshallah, this training session will has resumed unless I have some other commitment, because I had some official commitments, some tough official commitments in the last 2 months. Some of my team members were not there. My team lead was not there, so that's why I couldn't find time for this. But inshallah, starting this week, we are going to cover one section each week. Maybe if I have time, I can engage you guys 1 or 2 days earlier, and maybe we can have 2 sessions in a week as well. That all depends on if you guys are comfortable with that. Because from my side, I don't think I have any issue. So we can discuss it accordingly. Okay, fine. So thank you very much. Have a nice weekend ahead, and hope to see you guys next week as well.